Welcome to QuickBytes Education. Today's QuickByte is all about supervised learning, what it means, how it works, and why it matters in machine learning and data science. Let's get started. Imagine you are teaching a student with practice questions and an answer key. The student sees the question, then they check the correct answer. Over time, they start learning the pattern. Supervised learning works in a similar way. A machine learning model learns from examples where the correct answers are already known. In this lesson, we'll cover 5 things. First, what supervised learning is. Second, what features and labels mean. Third, how supervised learning models train. Fourth, the difference between classification and regression. And fifth, why training data and test data matter. Supervised learning is a type of machine learning where a model learns from labeled examples. Machine learning means computers learn patterns from data instead of being manually programmed for every single rule. In supervised learning, the data includes both the input and the correct output. The correct output is called the label or target. For example, if a model is learning to predict house prices, the input might include square footage, number of bedrooms, location, and age of the house. The target is the actual house price. The model studies many examples and learns patterns that connect the inputs to the target. To understand supervised learning, you need 2 important words: features and labels. A feature is an input variable the model uses to make a prediction. A label is the correct answer the model is trying to predict. For a spam email model, features might include the words in the email, the sender, the number of links, or whether the message has attachments. The label might be spam or not spam. For a student score model, features might include study hours, attendance, and previous grades. The label might be the final test score. So features are the clues, the label is the answer. Supervised learning usually follows a simple process. First, you collect labeled data. Second, you split the data into training data and test data. Third, the model learns from the training data. Fourth, the model makes predictions. And fifth, you compare the predictions to the correct answers to see how well the model did. The goal is not just to memorize old examples. The goal is to learn patterns that work on new data. That ability is called generalization. Generalization means the model can perform well on examples it has not seen before. One major type of supervised learning is classification. Classification means the model predicts a category or class. For example, is this email spam or not spam? Is this image a cat or a dog? Will this customer cancel or stay? Is this transaction normal or suspicious? In each case, the answer is a category. Classification is used when you want the model to choose from labels like yes or no, approved or denied, positive or negative, or one class out of many classes. The other major type is regression. Regression means the model predicts a number. For example, what will this house sell for? How many units will a store sell next week? What will a student score on a test? How long will delivery take? In each case, the answer is a numeric value. So here's the simple difference. Classification predicts a category. Regression predicts a number. Now let's talk about training data and test data. Training data is the data the model learns from. Test data is data used to check how well the model performs after training. This split is important because a model might do well on examples it has already seen, but poorly on new examples. That can happen when the model memorizes the training data instead of learning useful patterns. This is called overfitting. Overfitting means the model performs well on training data, but does not generalize well to new data. Testing helps us check whether the model is actually learning or just memorizing. Let's use a simple example. Suppose you want to build a model that predicts whether a student passes a test. The features might be study hours, attendance, homework completion, and previous quiz scores. The label might be pass or fail. The model looks at past students where the result is already known. It learns patterns like students with more study hours and higher attendance may be more likely to pass. Then, when a new student's information comes in, the model uses what it learned to make a prediction. That is supervised learning. Supervised learning is used in many real-world applications. It can help detect fraud, it can predict prices, it can classify emails, it can recommend actions, it can estimate risk, it can help businesses make better decisions from data. Many beginner machine learning projects start with supervised learning because the goal is clear. Use examples with known answers to predict answers for new examples. A common mistake is thinking supervised learning means a human is guiding the model every second. That is not what it means. The supervision comes from the labeled data. The model is supervised because it has examples with correct answers during training. After training, it can use what it learned to predict labels for new data. Here's what you just learned. Supervised learning is a type of machine learning that learns from labeled examples. A feature is an input variable. A label or target is the correct answer the model is trying to predict. Training data is used to teach the model. Test data is used to check how well the model performs. Classification predicts categories. Regression predicts numbers. The goal is not memorization. The goal is generalization, which means performing well on new data. And supervised learning is used for tasks like spam detection, price prediction, image classification, fraud detection, and customer churn prediction. If this helped you understand supervised learning, watch the full Data Science for Beginners playlist next. Like, subscribe, and keep building your knowledge with QuickBytes education, one QuickByte at a time.